Okay. Now let's see. Which of the following describes the solutions of this guy? Well, let's find the solutions of that guy and then we can describe them. X minus 3 squared equals negative 25. You may be able to start seeing this in your head, you guys, but if you don't, that's okay, just do it. Square root both sides. We get a plus or minus when that happens. And then here, these guys wipe each other out, and we have x minus 3 equals plus or minus square root of negative 25. If you need this worked out in detail, look back at the previous video, number 1, in 2.6. But we did learn that you could just square root the positive version of the number, and then the negative in the rad becomes an I. Okay. Now I have x minus 3 equals plus or minus 5i. I'm not done solving for x, you guys. I do need to add the 3 to both sides. So I get x equals, and because I want I to be the absolute last part of my answer, I'm not going to put the plus 3 on this side. I'm going to put the plus 3 in the front. Okay, so we've got 3 plus or minus 5i. This is a complex number. It is imaginary, okay? It's not real. But the reason it's called complex is because it has a real component with no I and an imaginary component, okay? Complex number. Okay, how many solutions is this, by the way? I've been saying this is a complex number. Technically, I was wrong. These are complex numbers because there's 2 of them. There's 3 plus 5i and there's 3 minus 5i. X equals. I've got myself 2 very not real solutions because of the presence of the I. Okay. Sydney made a mistake while solving this equation. Where's the mistake? Let's see. Sydney took this equation. Okay, wrote it down correctly. Check. Sydney decided to add a 6. I wonder why. Let's see why. Then 10 plus 6 became 16. Ooh, Sydney kind of completed the square by skipping a couple steps. Sydney divided that 8 by 2. Remember completing the square? 2-step process. Divide by 2, then square. And then after that, don't forget to balance. So let's see. Sydney divided the 8 by 2, got 4, squared it, got 16, and then decided instead of adding 16, I already have 10, I'm just going to add 6 more. So it's a little different than the way I showed you in class, but it works, okay? Added 6. So far so good. But then Sydney was supposed to balance. If you went ahead and added 6 to this side of the equation, you must also balance it by adding 6 to the other side of the equation. Sydney didn't do that. I guess technically Sydney could have subtracted 6 from the same side of the equation to balance it, but Sydney didn't do that either, all right? Sydney dropped the ball right here, all right, by not balancing. Okay, but then after that, Sydney got the 4, factored it, perfect square trinomial to the negative 15, square rooted both sides, got this, subtracted the 4. The rest of the work looks okay, all right? It's just that this should have had a plus 6. So this should never have been a negative 15. It should have been a negative 9. And then with the square root should have been a 3, whatever. Oh no, not whatever. We got to do it for part B. Okay, so let's go x squared plus 8x plus 16 equals negative 15, but let's fix it by also adding the 6 to this side. And then now this is a negative 9, and this is x plus 4 squared. Factor that. You can look back at my factoring video, or you could look back at the 2.4 homework video where I show that. And then here, we square root both sides. X plus 4 equals plus or minus. This is 3i. And then we still do need to subtract the 4 to get x equals negative 4 plus or minus 3i. All right? Could you have written 3i plus or minus 3i minus 4? Technically, it's the same. But actually, we need I to be the very last part of a complex number. You gotta write it like this. Okay, in a rad situation, we said it was okay to write it like this, though even that's debatable. Really, we need it like that. But in this situation, no. There's no justification for this. You weren't trying to avoid a radical. Please write it with I as the absolute last part of the number. Okay, now let's solve some equations. All right, here we are. Boop-a-da-boop. First thing, divide the 2. Okay, then we square root both sides. We get our plus or minus. We get x plus 3. And then plus or minus square root of 16. That's 4i. Now we just subtract the 3 from both sides. X equals negative 3 plus or minus 4i. That's perfect. Over here, okay, you guys, this is a trinomial. All right, you can't really isolate x. Can't just isolate x. We got 2 options, all right? You could try to factor it, but if you, not everything factors, you guys. If I add the 7 to this side, nothing multiplies to make 7 and adds to make negative 10, because the only things that multiply to make 7 are 7 and 1, and they don't make 10. So this is a failed mission. So here's our best friend. Our best friend is completing the square. That will let us isolate x. So let's do that. We got x squared minus 10x equals negative 7. I'm going to leave a little space for that perfect number that I need. I'm going to divide the negative 10 by 2. And then I'm going to square it and add it to the empty spot. Negative 5 times negative 5 is 25. Can't just add to one side. We balance by adding to the other side. And now we simplify. This x squared minus 10x plus 25, it will factor into that. And negative 7, that's 18. And then now we square root both sides. We get x minus 5 equals, we get plus or minus. And then we need to simplify the rad 18, okay? 18 is 9 times 2. Remember, you don't have to do the full factor tree if you could tell what the biggest square root that goes in there is. It's 9 and 2. So this is 3 rad 2. But you can keep going and get the 3's, and then they partner up. One of them gets out. The 2 doesn't have a partner. It stays in. Here we are. Then we add the 5 to both sides. And x equals 5 plus or minus 3 rad 2. We didn't get an I this time, you guys. Okay? Don't think you gotta get an I every time. We used to not get I's all the time. No I. This is a real solution. It's ugly, but it's very much real. And then over here, you could do the same thing, okay? I would, let's see, if I subtract this, I get 23. 23 is not going to make 8. It doesn't factor. But I would move the 26 over to get my x squared minus 8x, leave some empty space to complete the square. 3 minus 26 is negative 23. Then, remember, completing the square, you guys, it's divide 2, then square. And then balance. That's really all there is to it. So I divide this by 2, I get negative 4. I square it, I get 16. Added it to this side, so I'll add it to that side. and then I simplify. This guy will factor to just be that. And then this right here is 7, negative 7. Negative 23 plus 16. Feel free to use a calculator. Okay. And then now we square root both sides. And I get x minus 4 equals plus or minus rad 7. But that negative is an I. 7's a prime number. It's not going to simplify, you guys. And then I just have to add the 4 now to both sides. To get that x equals, I'm going to put 4 first because it doesn't have an I in it. And I'm going to make sure my I doesn't look like it's in the radical and it's at the far end. Here are the 2, very much imaginary, 2 complex zeros. Okay, let's look over here. Number 6. In the equation blah blah blah, p is a constant. What's the largest value of p that would result in only real solutions? Okay, let's see. I don't know. Negative 2 x minus 3 squared plus 4 equals p. You guys, I don't really allow something like a p getting thrown into the equation to trip me up. Remember, we don't change the rules of math for weird, right? Like, we just keep going. So what I would do to figure out what's going on with the solutions or the roots or the zeros or the x-intercepts or whatever is that I would subtract the 4. I would solve by subtracting the 4 first. And then I get negative 2 x minus 3 squared, and then it equals p minus 4. And then I would divide both sides by negative 2 divided by negative 2 to get x minus 3 squared equals p minus 4 divided by negative 2. Oof, run out of space. There's so much space here. I should have done it here. Okay. All right. So now, what does this mean? This means that the next thing I do is to square root both sides. And this is where the determination of whether my answer is real or imaginary happens right here. Because if the number in here is positive or 0, my solutions are very much real, okay? Only when the number inside the radical is negative do I get imaginary. So let's think about that. What I want is for p minus 4 divided by negative 2 to be either greater than or equal to 0. That's what positive or 0 means, that you have to be greater than 0 or equal to 0. And so now I gotta solve this. So what I do is I multiply both sides by negative 2 to solve for p. And I get p minus 4. Oh, something happens, you guys, when we multiply both sides of an inequality by a negative. This sign is going to do a flipperoo and become less than or equal to. And then 0 times negative 2 is still 0. And then I'm going to add the 4 to both sides. And that means that p must be less than or equal to 4 for this to work. So that means that it can be 4, it can be 3, it can be 2, it can be 1, it can be 0, it can be negative numbers, negative 1, negative 2. It can be all the numbers in between here, like 3.5 or 2.7, okay? But what's the largest number it could possibly be? 4. 4 is the absolute biggest number that would make this work out, okay? 4. That's it. Final answer. You guys, these problems are tricky. That was very tricky. Please remember that the one question right before spiral review is often incredibly tricky. Okay? Super duper hard. Might make your head spin. This might make your head spin. That's okay. Don't stress about it. It'll deepen your understanding. It's a great question, but I would not lose any sleep over a question like this. Okay? All right, let's move it along. Fill in the boxes using the digits from 1 to 9 to make each equation true. I don't wanna, but I'll do it. I'll do it for you guys. Okay, let's see. Digits can be used more than one. We just gotta simplify it. It's not as bad as it looks. Let's go PEMDAS this up, all right? Parentheses, exponents, multiplication and division, addition and subtraction. 8 squared is 64 minus 2 times 3 times 7 is 42. Okay. And now 64 minus 42 is 22. So 22. Okay. Let's see number 8. Negative 2 squared, that's a positive 4. Okay, oh, I love this. You guys, this is gonna be so relevant. I'm so glad I didn't skip this even though I wanted to. And when we do quadratic formula, all right, here's how I like to do this. I like to first only do this part. Next, only do this part, okay? So I get 4, and then I get minus, and then I go 4 times 3 is 12, and 12 times negative 1 is negative 12. I like to write it like that, you guys, okay? Because it's just too many numbers to mess with our heads, and then a minus and a minus do become a plus, but if you keep it in your head, you're gonna mix it up at least some of the time. I promise you'll mix it up at least some of the time. Now, minus minus is plus, so this is the square root of 4 plus 12, okay, which is 16. Which is 4. Okay, over here, I have 3, I have plus, I have 4 squared is 16, plus 9, and it's all over 15. Okay, this is 3 plus the square root of 16 and 9 is 25, all over 15. And square root of 25 is 5, and this is 8 over 15. You guys, these are so, oh my gosh, please do this. When we start doing quadratic equation, these are all the skills we need, simplifying these types of things. Okay, here we go. We got 4 plus a rad 12 divided by 8. Hold on. Rad 12, we did this earlier. 12 is 4 times 3. And 4 is 2 times 2, which means that we can break out the 2 but cannot break out the 3. So the 3 stays inside because there's only one 3. You need 2 to break out, okay? And even when you do, only 1 makes it. And divided by 8. And then I look at this and the boxes don't exactly align to what I have. Oh, that's because I haven't simplified. Look at this. The 4, the 2, the 8. I can divide everybody here by 2. This is a not reduced fraction, okay? Divide everybody by 2 and you'll get 2 plus a 1, rad 3, divided by a 4. And then this 1 is a little bit unnecessary. We don't need the 1. So now I can fill that out. Whew! Okay. All right, you guys.